Okay, go ahead, start, Dave.
Okay, yeah, welcome to the 17th, I believe, update of the situation in the pandemic that I've done. And what I'll talk about today is a lot of the same things I talk about, kind of look at starting at the whole world. What is the global situation in terms of outbreaks and new case growth? And then go through the global model and break it down by country and look at models for cases and deaths in countries, and then look at the US cases and deaths by state, and then California counties, models, cases and deaths, and then drill a little bit locally into what's going on in Santa Barbara and our immediate neighbors. And then talk a little bit more in depth about sort of the special topic this month is variants, what's the latest on the variants, and a little bit more detail, maybe than anybody really wants, but a little bit more detail into the mutations that give us the variants and why maybe that makes the virus behave in a significantly different way. And then an update on vaccinations, both in the world and in the US, and a little bit locally too. So a lot of charts to get through today. So overall, how is Earth doing with the pandemic? Well, the global daily cases have stabilized. They're not going down really anymore. They went down a lot from April, when India was particularly the most hard hit place, really, of any place in the whole pandemic. And that went down, but for about the last month, they've been pretty stable between 350, 400,000 cases a day. So still a lot, and but about half where they were at the worst of April. In terms of in which regions things are happening, Latin America is now the biggest source of cases on a region basis. About 40% of the new cases each day come from Latin America. South Asia, of course, where India is, has declined from, it was actually over half the cases at one point. It's about 20% now of global new cases between India and particularly Bangladesh, Nepal, Pakistan. North America remains quite good. It's about 3%, so less than 5% of the global new cases, which is down a lot since early in 2021 when it peaked. And almost all the resurgences like we had in the US are subsiding. There are a few outbreaks, in each region that look out of control and where daily new cases are increasing a lot. And I'll show you which ones those are. And then in the variants department, we continue to see variants of concern emerge, which, will be a fact that as long as we have hundreds of thousands of new cases a day, we're creating, very huge numbers of mutations, and some of those will be useful from the virus perspective. And if they succeed to propagate, they'll become a variant. Vaccinations are growing a lot more in other places than in the US, but they are growing, and I'll show some of those data. And the bane of somebody trying to make a model, the practical problems that the countries have trying to collect and get all the data right continue to be challenging. So in the latest few months, it's been Nepal, France, and Peru that have dumped or removed very big numbers of cases from the data set, kind of without fixing it. So it makes it difficult to believe some of the conclusions of the model based on those data. All the information that I have here is as of Friday. So I typically pick Friday. So I have a couple days to make all these charts. And my source is the Johns Hopkins database they post to GitHub. And that's from the 25th, as I mentioned. So this is the progression of outbreaks chart. And from last February through now, and these are almost 2 months apart now. I've kept this at 10 just to keep it sort of manageable. So these rows are getting a little bit farther apart in time as time goes on. there continues to be very little growth here in the small outbreaks. So there aren't, the virus seems to be pretty much everywhere. There isn't a lot of growth in small outbreaks. There has been a little bit more growth in the last couple months in the medium and large outbreaks. So about, on average, about a 10% increase in the outbreaks between 200,000 and 2 million, which is most of them over here on the right, plus a bunch below. The top 50 outbreaks now are all above about 450,000. So a lot of these are smaller than the ones that I model. I model the 50 largest cumulative case numbers. And we did have notably one additional 20 million case outbreak, which is India, which joined the US as being the only two countries with more than 20 million confirmed cases. So you can see these. The other change that is notable is a couple countries dropped out of this top 50 that I model. Paraguay, Bolivia, and Nepal entered the top 50. Nepal has been in and out. I believe Bolivia was in before, but I think Paraguay has not been in the top 50 until now. And it is indicative of the ongoing challenges in Latin America to control the outbreaks there. This shows how the cases have progressed across the regions. So you can see here is, this sort of bright green is North America. So you can see here, December, January, when the US was really half the cases basically in the world were happening in the US. This more lime green is Latin America. And you can see now it's about 40% of the new cases. This, I don't know, it's kind of purpley, this light purple, that's South Asia. It is coming down, but is still the second biggest region. And then the other things that are new, Southeast Asia, had some early cases and managed to keep things under control. That's really no longer the case. There's couple at least outbreaks in Southeast Asia that are growing, and they're around 10% of the new cases. Similarly, Sub-Saharan Africa, substantially in South Africa, but also a couple other African countries are now growing. So those are really the four regions most impacted right now in terms of the share of daily new cases. And Europe, which are these little stripes in here, is East, West, and not East, West, North, and South Europe. And then this is Eastern Europe, which is a little bit larger, mostly because Russia's having a bit of a resurgence that you'll see. So these are the models, and the R squareds are the individual models. And of course, they're always a little bit better for cases than deaths, just because of the large numbers of cases means there's a little less noise. But they're all pretty good. These outliers down here are mainly the result of discontinuous data changes from administrative corrections that Turkey and Nepal had to do. This is the cumulative graph of the 10 largest outbreaks and the globe. So the black dots are the actual numbers, cumulative, and the black dashes are the sum of the country models. You can see the US here, India here, both of those two outbreaks are pretty much leveled off. Brazil still on a slightly concave upward trajectory in terms of how the model is fitting it. So daily cases still increasing. And then the remaining large outbreaks in Europe and Latin America predominantly are not peaked, with the possible exception of France, but also not surging like you see in Brazil. And you can see that in the derivative or the daily new cases graph, which I find a lot more useful. The waves here of the US, we had these four distinct waves. The India peak that was really, for a peak this large, was as sharp as we've seen in I think I've seen at any outbreak. So I'm not sure the dynamics of that, but it rocketed up, but it came down faster than any of the other outbreaks that had big surges like that. And then this purple, of course, is Brazil, which isn't being predicted to peak. If it ever does, you can see it kind of has just been on a slow roller coaster up throughout the pandemic. You'll see that on the graph. But if this indeed is its peak, it doesn't look like that'll happen until the end of July. These are fatalities, and you can see it's a little bit concave downward. Fatalities are leveling off. This is Brazil, still increasing. This is Russia, also increasing. I forgot to mention that on the case graph, but you'll see its individual graph here in a few slides. And these are daily deaths. And you can see Brazil looks like it's peaking a little bit earlier in fatalities than in cases, actually. And Russia is, the model is fitting it to be a fairly substantial increase. So let's look at those individual ones that make up the model. So these are the 5 largest outbreaks. They've been the same since April, since Turkey actually passed Russia and to be the 5th largest outbreak. The US, India, both down much lower than their peaks. I mean, India, 50,000 cases a day is still a lot of cases, but it's a lot less than where it was at about 400,000. Brazil, you can see this kind of just never quite turning the corner and bringing daily new cases down, and the model's predicting it to go up. France is down low and doesn't show signs of resurgence. And Turkey looks like they've also got things pretty good control. This is the data correction in December. So once again, not all of them are going down, but of these 5, the only one that really is still not turned the corner is Brazil. But the 6th one, Russia, you'll see is similarly out of control right now. Western Europe, overall, pretty good progress, except in the UK. And I have a slide, the next slide, I'll talk a little bit more about that, but you can see that the cases in the UK are going up significantly. They've been going up for almost 6 weeks now. And you can see that's a lot different than France. You'll make the comparison with fatalities on the next slide. But Spain, Germany, and Italy all, very low cases compared to their peak. Spain's a little bit stuck at about 5,000, but Germany and Italy are down below 1,000. So what's going on in the UK? Well, one thing that's interesting, this is UK fatalities over here. And you notice that 6 weeks ago, cases started going up, and throughout the pandemic, 3 weeks after a surge in cases start, typically you see deaths start to increase. That's about the lag time between those 2 curves. And that's been quite consistent. But we're not seeing that in the UK right now. It's been almost 6 weeks and there is not an increase in deaths. So one hypothesis about why that might be, well, one other maybe thing that might be puzzling is that if you look at the vaccines here, vaccinations, and here's the US, but then these are the other big outbreaks in Europe. The UK has the highest degree of vaccination of their population of anybody in Europe, but they're seeing a surge in cases. And they also, in this graph over here on the right, is prevalence of variants based on samples and sequencing that's done in the various countries. And you can see that UK has this big green part here. That green is the Delta variant, or the also known as B1.617.2, or the India variant. And it has a very large fraction of its virus population, at least that's been sampled, is the Delta variant. And one thing about these graphs is these, as soon as sequences start coming in from samples and get posted to the sort of clearinghouse that keeps track of all those globally, they go up on these graphs. So sometimes the very rightmost data on the graph are not, it may only be a dozen sequences. But even the week before last, UK was overwhelmingly seeing the Delta variant. So that may be contributing to the surge, and that it is believed that the Delta variant is going to be better at evading immune responses like those that are triggered by the vaccine than the sort of historical COVID, or even the Alpha variant that is the UK variant, which is this brick red part that used to be what it was prevalent in the UK before the Delta variant. So it may be that this Delta variant is able to evade the vaccine and make people sick, but as I think we saw a lot consistently in the vaccine trials, the vaccines may not be 100% effective against getting infected by COVID, but they seem to be close to that in terms of preventing you from dying from COVID. And that may be what we're seeing in the UK data, that they're seeing tens of thousands of new cases, but not fatalities, because they have a very significant fraction of their population vaccinated. And maybe they still get sick and become a confirmed case with the Delta variant, but they don't seem to be dying based on the data. So anyhow, that's I thought that was an interesting way to look and maybe explain what's going on in the UK right now, because they definitely are backsliding in terms of having the cases being under control, but not fatalities. In Latin America, I don't know, people that have seen these, 1 month I say, oh, Argentina and Peru are really bad, but Mexico and Bolivia are okay. And then the next month so the constant is Brazil is always bad. And then kind of Argentina, Mexico, Peru, and Colombia that have been the next 4 biggest outbreaks take turns being either surging or coming down from their last surge or surging again. So this month, Colombia and is certainly surging. Mexico, the model is saying it's coming into a resurgence. It's been 6 weeks or so. Its cases have been increasing and increasing at an increasing rate as time goes on, which is, of course, the hallmark of a resurgence. So those two seem to be the ones in a little bit of trouble. Argentina and Peru, not so much, down, at least 50% from where their peaks were. Then a little bit about Chile. So this was, by not giving an update last month, missed an opportunity for an interesting observation about Chile. So Chile has the highest vaccination rate in Latin America. It's up here at the top, challenged really only by Uruguay, who doesn't have much of an outbreak anyway. But Chile, right at the time they were crossing 50% of their population being vaccinated, was having a record surge in cases here in early June. And it was a little puzzling why it was so bad in Chile with that vaccination rate. And so when you read the literature about that, 93% of the doses were the 2-dose Coronavac vaccine, which is the name of the vaccine made by Sinovac, which is a Chinese vaccine producer. And in Chile, they studied the effectiveness, and single doses were only about 3% effective in that study, and references down there, but which is not very effective. And I think particularly the Chilean government was celebrating that they were getting such a successful vaccine campaign, because they really did clobber everybody else in South America in terms of getting vaccine delivered. And after people got a dose, they relaxed the restrictions, and there was a bunch of travel, and the single dose being so ineffective led to this resurgence. Now it's coming down now over the course of June. kind of a reminder to me of, there's only downside to just, going nuts too early. So, let community transmission subside, get everybody vaccinated, get the second dose, and then start loosening things up. And I think Chile, both due to the characteristics of the vaccine that most people had, as well as their reaction to getting the first dose, jumped the gun a little bit. But you can see that even though cases are a lot higher, fatalities are not, although they are still increasing. So we'll keep an eye on what happens in Chile. But I thought that was also an interesting dynamic to look at in the interaction of the sort of realities of the outbreak and the capabilities of the vaccine and how it's delivered and how the society reacts to it all change the outcome of the outbreak. In Western Asia, most places are declining. There is some, you'll see Saudi Arabia's, I don't think I have Saudi Arabia's graph in here, but there is some growth in Saudi Arabia. It's an odd behavior. It's just a slow, steady growth. It's not a big surge. But other than that, it's declining off its peak. Mostly, Iraq has a little cowlick on their outbreak here. Model says it's peaking, but, we'll see. But Israel certainly is looking fine, Jordan. And Iran, as they have many times, as being one of the places that was at an early outbreak as it moved out of China, they've fought surge after bigger surge, not unlike the US. And they came down from their most recent one that was in April, and they're down less than half of that, but a little bit either flat or starting to tick up a little bit again. I don't know, but there isn't really an out of control outbreak like you'll see in a couple slides. Eastern Europe overall looks quite settled down, like almost all the rest of Europe, Western and Southern and Northern Europe, except Russia. Here's Russia in the upper left, and you can see they just have anytime these little X's gets far enough apart, you can see space in between them. You've got lots of case growth, and that's what's happening right now in Russia. So they're up to 2/3 of the peak of the all-time peak of the pandemic, and no signs of inflecting yet. So I'm not sure what's going on. We'll see a little bit, maybe something in the vaccination part that explains part of it, but it's just been an interesting outbreak. They were stuck here at 8,000, 9,000 cases a day for months, which is hard to do to stay the same. Usually it's either going up or going down, but to be for that long at a constant daily new case level was unusual. And now whatever changed in the way people are behaving, it's tipped it to the each case is creating more than one new case. But Poland, Ukraine, Czechia, Bulgaria, almost all the other places in Eastern Europe that I model are all down at pretty low levels compared to their peaks. So where is it bad? So here are the 3 of the 50, so usually I can, well, not usually, but 4 months ago, I could fill a page with these, of course. These are the 3 that really, that I haven't shown yet that are seeing surges. There's South Africa, which is just about to, exceed its all-time peak. Indonesia, which has, and there are other outbreaks at or just down from their all-time peaks. Malaysia, for example, the Philippines is down a little bit, but just recently it hit a very significant high. And then Bangladesh is going up quite a bit. So these are probably the ones that, along with Russia, maybe the UK, you could say, that look to be struggling the most to get cases going down, daily new cases going down again. So looking at the US states, for the US states, I model all 50 plus Washington, DC. So there are 51 models for cases, 51 models for fatalities. They're predicting about 35 million cases for the US. So not, it says we're pretty close to the end of this outbreak, and about 750,000 deaths. So which would work out to about a 2.2% case fatality risk. Right now it's about 1.8. So, you'd expect because of the lag that as the outbreak winds down, the case fatality risk will drift up a little bit. I don't know if it'll really drift up to 2.2%, but anyhow, that's what the model's predicting. So the total case prediction is the same as last month. The deaths are essentially the same. It was 730, I think, or something last month. Resurgences have basically subsided in all states. I'll show a map in a minute. Daily new cases and fatalities really have sort of leveled after declining. So they're not declining so much anymore. So just, and again, putting things into perspective, over the last month, about 0.1% of the US population has been confirmed as a case. So that's about half as much as the month before, and much slower, when it was several percent a month in some periods at our peak. So much slower than it has been. But still, it's not trivial. There's 12,000 new cases, I think, on Friday. Is not a trivial number of cases. In the same time, as about 0.1% of people got confirmed as a case, about 4% of the population received a vaccine. So that's good. It's about 2/3 as many as in the prior month, so going down, and only about 1/4 as much as the month before that, when it was about 15% of the population in that month received the dose. So vaccinations continue to go down a little bit. I'm calling them leveling off. I'll have a graph later on about that. So these are the 10 biggest outbreaks in terms of states and how they sum to the state model, or the country model as a sum of the states. And you can see, very much leveling off that's happening in the cumulative cases. And you don't see any real things turning uphill here in the daily new case graph. But you see overall, when you add them together, it's not really going down so much. It's pretty much leveling out at in the neighborhood of 10,000 cases a day. So much better, much better than it has been for a long time, really, since last March or April, but not really low yet. And these are fatalities also leveling off, and you can see none of the states have an upturn in cumulative fatalities going on. They're all pretty much leveling off. And you look at the national data on daily new fatalities, similar to cases, not so much going down, kind of leveling off. There's a slow decline in the sum of the model's prediction, but not coming down steeply like it had before. So where are the new cases? So these are the 7 cases that 7 states that accounted for the most cases over the last 2 weeks. And this column is the share of new cases that occurred in each of those states. And this is the share of the population that lives in each of those states. So you would expect the expected amount of share of cases would be the same as the population if all the outbreaks were behaving similarly. If the share of cases is a lot higher than the share of population, then that outbreak in terms of the population case rate is higher, and then it gets coded in red. So I make them bold in red if their share of cases is more than 25% greater than you'd expect based on their share of the population. So Texas, California, and Florida all, were within that 25% spec. Texas, actually, it was 23% above its population, so just below being red and bold. But anyhow, they're not. They're but California is significantly below the share that it's expected. Missouri, Washington, Arizona, and Colorado, which are not, big outbreaks in terms of the total number, but right now they're having much more than their share of cases. Particularly Missouri has almost triple the new case rate that we're seeing in the country as a whole. And these are the outbreaks, and you can see none of them have big upturns. Missouri has a little bit of one. It's been going on for almost a month, so it's probably real. The model fits a little bit of a uptick there, but everybody else is pretty much down or leveled. Again, with the exception of Missouri. So, and once again, in aggregate, these are about 40% of the population, about 40% of the new cases. This is the way that the country looks in a map view. So, as in months past, the states are color coded. If they're red, it means they hit an all-time new high in daily cases in the past week. So no states did that this month. No states did that last month, and no states did that the month before. So this is the third month in a row that no state hit a new high in daily new cases. They're orange if they had more cases in the last 7 days than in the 7 days before that. So last month, there were only 4 states that had more cases in that week than the week before. This month it's 19. So that, went up. And I think as we're seeing the cases level out, if the number of new cases is about level, then we're going to see about half the states have more cases and about half the states have less cases. Everybody can't be going down and have the cases be level. So it's not that surprising. And as I said, there's no big surge happening in any of the states, but it's also not really going down very much right now. It's just stuck at the level where it is. California is one of those orange states. We had slightly more cases last week than the week before. And so, speaking of California, let's look at the county models. So I modeled the 30 biggest outbreaks at a county level for California. Right now, the model predicts about 4 million cases for California and about 70,000 deaths, which is about a 1.6% case fatality risk, which is very close to the predictions for the last 3 months. So the outbreak has been pretty well behaved. A lot of what happens in California depends on what happens in LA County, since that's about a quarter of the population. And you can see cases and deaths remain very low. As a state, our cases are a little bit under a 30th of where they were at their peak, and deaths are about a 16th of where they were at their peak. So much lower. Not quite as low. Deaths lag a little bit, so they're a little bit higher compared to the peak than cases. This is the sum of the county models. These are the 10 biggest county outbreaks, notably Riverside, Pass, San Bernardino. They've been kind of neck and neck here recently. But other than that, not much change, and everybody looks pretty level. When you look at the daily new case graph, nobody's turned up very much. You can see sort of some flattening and some leveling out of the cases, both at the state and the county level. It's a little bit hard to see because of the scale, but nothing's going up very much, but it's also several of them are not really going down very much either. These are fatalities, which show a similar trend. You can see it's not quite as flat because of the lag in fatalities, but definitely flattening out. And you see a little bit of a, fatalities have, all these data have some 7-day seasonality to them. So often on Fridays, there'll be a little bit of an uptick in the data. But certainly fatalities not going down as quickly as they had been previously. Zooming in even more locally, Santa Barbara County. New cases are about 2% of the peak that we had in mid-January. And the last time we saw new cases at this level was May of 2020. So 13, 14 months ago. Testing positivity is under 1% now, which is good. Hospitalizations are way down. The last time we had this small a number of people in the hospital with COVID was March 28th, 2020, which is very, very early in the pandemic. So you can see the hospitalizations here in the lower left. Daily deaths have really flattened out and dropped. I think we went a whole month without a fatality in May. We've had a few in June, but low levels of fatalities. And the CFR is better than the US, better than California overall, about 1.3%. And it's been pretty steady the last few months. And the prison hasn't had a new case in a couple months. After, they tend to get them in all of a sudden a bunch and then nothing for a long time, probably because of the way they're measuring it. Neighboring counties all have pretty similar stories. So this is Santa Barbara, a little bit different form of the model. This includes the prison in here. This is Ventura. San Luis Obispo, we all had peak at about the same time. When you look at our overall population infection rate, Ventura is a little bit higher, maybe because of the proximity to LA, but all under 10,000 per 100K. Kern, which technically we have a small border with Kern, is notably higher. It's about 12% of the population has been confirmed as a case. But it also is down quite low from its peak. So similar story across the US, even more, I think, significantly in California, things are down and look under very good control. And certainly locally, that is true also. So this will be the last time I show the flu season thing. So the flu season ends with a shutout, use a sports analogy. So by having COVID restrictions in place is what I attribute it to. We went an entire flu season without a single positive flu test in Santa Barbara County. So we conducted about 2,800 tests over the course of this flu season, and these little orange dots are the percent positive, which has been at 0 the whole time. So it's, it certainly shows some of the restrictions are a little draconian for the flu, but probably just wearing masks during flu season, as you actually see in a lot of countries, would do a lot, in my opinion, to retard the transmission of the flu. It certainly did this year. So I'll stop showing that till next flu season. All right, variants. Updates on variants, and then a little bit of special topic on mutations that I hope is not boring or confusing, and has great risk of being both. So this is the update to the tree of observed variants. Next strain changed their color coding. If for people who remember the color coding of the graphs from previous months, these other variants of interest and concern, they all colored them gray, and then the colors of the sort of more recent variants of concern. We're up to a variation of 62 is the most deviance in terms of number of distinct base pair changes. They're not pairs, base changes in the RNA compared to the original virus. It was about 50 last month. So on average, the population of variants swimming around changes by about 2 bases a month. And interestingly, I don't know if it's significant or not, but 4 months ago, this rate estimate was 22 substitutions a year. And then last month it was about 24, and now it's coming up, it's over 26 substitutions a month. So there is a little bit more entropy in the genome over time. And again, I don't know if it's significant, but it has been consistent 4 months in a row. It's been increasing. This is shrunk down because it has a little bit different timeline, or because I wanted it to line up with the timeline. So this is July and this is July. You know, this goes all the way back to January. And this is the fraction of the whole, all the sequences that were submitted to GISAID, the clearinghouse, globally, the fraction of the different variants of COVID that were in that time period. So you can see it went from these early clades 20A and 20B, they, you know, it goes A, B, C, D. So not surprisingly, A and B are over here. And I have coded in here the WHO designation and WHO, I guess, but and I have on the next slide, I'll have a little bit decoder ring for the different ways to talk about the variants. But for this graph, it was simple just to put alpha, beta, gamma, and delta in here. But the alpha, or the UK variant, is here. Beta, the South Africa variant, is here. Gamma, the Brazil variant, is here. And then delta, the latest Indian variant, is here. And so you can see beta is losing share. Alpha is pretty much steady. Gamma is pretty much steady. And delta is gaining share globally, of new cases. And, you know, as expected, as long as we're churning out hundreds of thousands of new cases a day, we're going to be churning out variations of the virus, some of which will be better suited to infect people. And here's the latest cheat sheet. So as the report I sent around last month, even though I didn't do a talk, at that time, the Delta variant was just a variant of interest. And it was pretty clear it was going to be a variant of concern even then. And officially, it is a variant of concern now. These are the updated assessment of the CDC on what the clinical behavior of these variants is that makes them be a variant of concern. Higher transmissibility, particularly for alpha and beta. Probably also for delta, even though it doesn't share the exact same mutation that I'll talk about later in the spike protein that is broadly associated with the higher transmissibility. P1 shares this same mutation, but hasn't officially been, I guess, clinically demonstrated to be more transmissible, although it's widely believed it is. But there isn't a number that the CDC gives. This column is the impact on its ability to evade attack by antibodies, whether it's from monoclonal antibody treatment or immunity brought on by vaccination. So minimal for the UK variant, moderate to significant for, I should probably settle on one nomenclature. I'll just stick with the Greek letters. So minimal for alpha, moderate to significant, depending on whether it's the sera of an infected person or monoclonal antibody treatment, moderate to significant for beta and gamma, moderate for these two epsilon California variants. And it just says likely in the CDC. Again, it's the Delta variant is new enough that there isn't as much published material that lets them put a label on it like significant or moderate. So it just says likely. And the only one where really there's been demonstrated that the disease severity is increased is with the alpha variant, the UK variant. Still, none of these have been designated as a variant of high consequence, which would mean there's clear evidence that the prevention measures. So, for example, if there was something where the vaccine just didn't work and people got sick and died, even if they were vaccinated, that would be a variant of high consequence. And the CDC has not designated one yet. And it certainly doesn't look like these should be based on the data so far. So here's how the variant progression is going in some countries. So this is the UK, I already showed you that one. Big takeover by the Delta variant. This is the US, so we had a big takeover by Alpha in the late spring, early summer. The Gamma variant, P1, the Brazil variant, grew, got up to 10 or 15%, and it stayed pretty steady. But the alpha variant is really getting displaced, some extent by gamma, but really by delta. So delta is, about a third. You'll see on the next graph, I think. South Africa, still a lot of the beta variant, the South Africa variant. We're seeing some delta come in, but dominated by that. Similarly, Brazil is gamma or P1, makes up most of the cases in Brazil, and in a lot of Latin America that you're seeing surges. A lot of those are associated with the gamma variant. And then India, not surprisingly, the Delta variant. And also, just as in the UK, in India, the Alpha variant was really displaced, over a month or two by the Delta variant. And I'm starting to see the early signs of maybe that happening in the US also. These are the CDC numbers, which lag a little bit, those next strain numbers that I showed in the previous graph. But here, and again, changing the way we call things, just to keep it confusing. B.1.617.2 is Delta. P1 is the Gamma Brazil variant, and this is Alpha, the UK variant, and this is the California variant, Epsilon, I think. So B.1.1.7 getting displaced by P1 and the India variant. And, in California, a couple weeks or a month ago, it was about 20%. A few weeks ago, you'll see in the next graph from the next strain, more updated data, it looks like about 30%. California is now the Delta variant. And here we go. So this is, again, from the GISAID, which is Global Influenza Surveillance and Information Database or something. Anyhow, it was set up for flu and keeps track of all the various flu viruses and is now, got a very big section on COVID. And so in California, you can see this is the Delta variant. It's about 30% in the latest week reported. And it's enough cases to be, to believe, that it's growing. The absolute number has got a big uncertainty around it because in this time period, there aren't a lot of cases, a few dozen sequences. New York, and then I put Missouri in here. Missouri is 60% Delta variant. Again, a little bit small number samples, but a few dozen samples, 60% of them are the Delta variant. And you look at the other states where it's significant, Utah, Nebraska, Nevada, New Jersey, and Kansas all have more than 25% of the most recent sequences from those states are the Delta variant. So it is seems to be the latest one to be making its way around and displacing the other variants in the US. P1 overall, in the US is kind of old and steady. We'll see, but Delta is definitely growing. And here we are in Santa Barbara County. It's a little bit hard to interpret the more recent data in Santa Barbara County. So here, we had these California variants early on that got displaced by the Alpha variant, here the darker orange. And then P1 came in, that's this most dark orange. Interestingly, in April, there was a Delta sequence submitted, just one. We've only seen one in Santa Barbara County. And then we haven't seen one since then. But notably, and in June, 100% of our sequences are all the Alpha variant, but it's 100% of one. So there's only been one sequence returned for June so far, even though it's June 25th. So it's a little bit more of a lag, but it's also, we have a lot fewer cases. So, we can't sequence hundreds of cases when we're not getting hundreds of cases a month anymore. So these down here are the actual number of sequences. So you can see we sequenced 300 of Santa Barbara County in February, 200 in each of March and April, about 20 in May, and so far just 1 in June. So with few cases, I mean, there isn't much virus going around if you're not having many cases. So, but it's also hard to know, of those few dozen cases we got in the month, what was the distribution of variants, and is harder to tell just because there are very few sequences that are done. So I'd rather have fewer cases and fewer sequences than the other way around, obviously. Okay, so one of the things I started to look into was, you know, we have these mutations associated with the variants, and they cause differences in the way the virus behaves, the way it interacts with our bodies, the way it interacts with our medicines. And so what is that about? What can I understand about that? So some of this may be very elementary, and I apologize if this is insulting because it's very basic, but just to make sure everybody kind of is starting from the same spot in the conversation, talk a little bit about the mutations and how they get expressed in the virus and why that leads to differences in the way the virus behaves. So just to go over, review proteins. So proteins are basically polymers. So they're, you know, very similar to a plastic molecule like nylon. It's the same basic linking group as in nylon polymers. But it's made up of hundreds or thousands of amino acids strung together. And there are 21 different kinds of amino acids, and they can vary each spot. So it's a lot different than man-made polymer, where you may have 2 or 3 different things, but it's really just one polymer. It's orders of magnitude more simple structure than a protein, even though they're sort of the same class of material, because of this spot by spot by spot ability to build a protein up of 21 different monomeric amino acids. So it's a huge range of things that proteins can do because of this ability to change the characteristic of it. And then the amino acids interact with each other, and I'll talk a little bit more about that. And so it creates 4 levels of structures for proteins. So there's the primary, which is just what's the sequence. It's, you know, amino acid 1, 2, 7, 6, and that's the primary structure. And then after you get all those together, there'll be some local structure formed, like a helix or a sheet, that gives the protein itself some 3-dimensional structure. And then those will fold on each other. That's the tertiary structure. And then, for example, in the spike protein for COVID is made up of 3 polymer molecules that all form together in a particular structure, and that's the quaternary structure. So it's very complicated structure to a protein, and takes huge computers hours to model how these proteins are going to fold based on all the interactions between these different amino acids in the different positions. So so that's the initial very basic thing about proteins. So, and the way that the proteins are constructed is, you know, we have messenger RNA, which is the genetic material in the COVID virus is messenger RNA. And it's a sequence of about 30,000 different bases. And the bases is one of 4 types, A, C, G, or U, and in some sequence. So that's all it's almost like a file on a hard drive. It's except instead of 1s and 0s, it's 1 through 4s. It's one of 4 things in a sequence. And as that pattern is turned into a protein in a ribosome, which is a structure in the cell, each 3 base pairs corresponds and is mapped onto one particular amino acid. So in this case, when it's GCA, it maps onto alanine, which is one of the amino acids. And in this case, it's GUU that maps onto valine, which is another amino acid. And so as the ribosome reads the messenger RNA and it assembles the protein, you can see the amino acids are changing in each step based on what the messenger RNA tells it to do. So these 3 base codons are what inform each amino acid in the sequence of the protein. So when mutations occur in the virus, they occur in the RNA, but they get expressed in the protein. And so the effect, how it affects how the virus behaves is how it gets expressed in the protein. But where it actually happens is in copying the RNA and mistakes in that. So this is a chart of the common mutations among variants. So many of these variants share some mutations. One of the more famous ones in mutation circles maybe is this N501Y. So S:(N501Y, which both the alpha, beta, or all the alpha, beta, and gamma variants have, and is attributed, I think, as I mentioned on an earlier slide, to greater transmissibility. But there's several other ones, and some of them you may have heard of, L452R, which occurs in the Delta variant, and E484K, which is one associated with evading antibodies, and that is here. You can see it's in the beta and gamma. It's a little bit different in kappa, but it's also in P2. So very many of them have this at the 484 position. These are the variants, and these are just, each row is one particular mutation, and it shows up each place it has it. And this is one of the ways that they infer what the likely family tree of all these variants are. That the one that I showed at the beginning, the variant section, is, okay, all these 5 are the same, but it has one different. So it must have come from this predecessor that had those 5 mutations already. It's very unlikely that 4 of them happened, and it came from a different ancestor virus. So there's a lot of complexity in mapping the most likely phylogenetic tree of these variants done by these mutations and their similarities and differences between other versions of the virus. So what does that mean, N501Y? Why is it designated that way? So S just means it's in the spike protein, so the S:, and pretty much all the mutations that we're going to talk about are in the spike protein. So they're the face of the virus to the outside world, whether it's to the cell it wants to infect or the antibody that's trying to prevent it from infecting it. It is interfacing with those parts of its environment with the spike protein. So you see most of the mutations of note are in the spike protein. N501Y is the code for what mutation happened and where. So the old amino acid was N, which is asparagine, which was the 501st amino acid in the spike protein. And now it's Y, which is tyrosine. So how does that happen? Well, it's that 3-letter codon. And when you look at the RNA sequence for asparagine, where it started, is either AAU or AAC. And so tyrosine is either UAU or UAC. So these last 2 were the same, but look, the first one was supposed to be an A, but in one of the millions and millions of copies of virus that was made, that A was mistakenly changed to a U. I mean, mistakenly, it assigns more agency probably than there is, but anyhow, a correct replication would have been an A, but instead it was a U. So miscopied to U, and now when the ribosome reads that and turns it into a protein, now it's going to put a tyrosine there instead of an asparagine. So who cares? Get into that. You'll see it really does make a bit of a difference. So this is some images of the structure of the spike protein, which is made up of 3 protein molecules that are coiled and folded and then stuck together to make this spike protein, which has these 3 lobes looking at it from the top, and that when you look at it from the side, it looks a bit like a T. So, and this is where N501Y is, which is right near the top. These are the locations of L452R, and these, again, top view E484K, which are 3 of the more important mutations in terms of transmissibility and evading antibodies. So what happens when N becomes Y or L becomes R? Why does it make a difference? So these are the 21 amino acids, and this is the way we draw organic molecules. Typically, many of you will have seen these things if you took organic chemistry. So in N501Y, we change from asparagine to tyrosine. So we change something from an amide, which is a polar but a very weak base, to something that's aromatic, very different character, and it's a weak acid because of the phenolic hydrogen here. So at that spot on the protein, even though it's just one change, remember that it was kind of right on the tip of the spear that is the spike protein, completely changed the chemical affinity of that side group. The amino acids are all the same structure, but just with a different piece of functionality hanging off of a different side chain. And these are all the different side chains. Similarly, E484K, it changes from a negatively charged acid residue. It's normally negatively charged in serum pH to something that's a positively charged base. So again, a complete inversion of the chemical character of it. And L452R, also associated with immune evasion, changes from a nonpolar hydrophobic, something that's like an oil, to something that's very polar, charged, and reactive, this guanidine residue. So it kind of ties together, at least tied together for me, how you go all the way back to the beginning. You make one mistake in copying one of the bases in the messenger RNA, and it substitutes randomly one amino acid, makes a significant change in the chemical potential at the one point in the spike protein, and it just happens to be something that makes it stick more. In this case, the N501Y, they believe it sticks more to the target cell, binds more strongly to the target cell, and allows a smaller dose of virus to infect someone and makes it more transmissible. So I think enough is sort of understood about how all this ties together. You can kind of build an explanation after the fact, but of course, these are all being generated randomly. So that's probably too much on mutations, but that's taken three of the more famous mutations, famous as mutations go, and going back to what happened in the gene to what happened in the spike protein and why it made a difference in the behavior of the virus. Okay, last section on vaccines. So here for countries, selection of countries, the percent of the population receiving at least one dose of vaccine. And so here's the US, we're doing pretty well, but certainly flattening out, about to be passed by Germany and France in all likelihood. We've already been passed by the UK and Canada. China is just this one point because they don't report very often on how many vaccines they've delivered, but when they did report, it was a whole boatload of them because it's 40% of their population, which is enormous. The other interesting thing is if you remember the graphs of who's doing badly, these four, Russia, Indonesia, South Africa, and Bangladesh, were all in that category. very low vaccination rates, under 20% for all these countries, and significant case growth. But on the other hand, Brazil is also not doing well, not quite as exponential as these guys. But it's up in the 30s. About a third of the people in Brazil have now received at least one dose. That's like 70 million people. And the UK is up here near the top, and they're having a surge. We kind of talked about that, may be associated with the Delta variant being able to evade the vaccine. But it's just interesting that of the larger countries, the ones that are very much lagging in vaccines are also the ones with out of control outbreaks right now. And globally, really is pretty amazing. Globally, about 1 out of every 5 people on Earth has had at least one dose of vaccine. It is a lot of doses of vaccine. So we're doing well, but it certainly is quite varied among countries. So some countries with very bad outbreaks are way behind, and some countries are quite farther along. In the US, these are the daily doses administered in US states. So you can see it went up and up and up, and in early April, it really peaked where, we were vaccinating about 1 person out of 100 a day, which was around the peak. It's now down here to around a quarter of where it was. It was going down. It seems to have pretty much leveled off to this level for about 3 to 4 weeks. The states remain pretty tightly grouped. Not you don't have some states just down here and some states way up here. They're kind of going together, but there is variation. So where we've gotten to, 54% of the total population has received at least one dose, and about 46 are fully vaccinated based on the latest CDC information. 88% of those 65 and older have received at least one dose, and 78% are fully vaccinated. And those numbers really didn't change very much in the last month. They went up by 1 or 2% only. And overall, it's not changed by a lot, but it's changed by a little bit more than that. So, and these are, pretty good. We get up to 80% of a population fully vaccinated is a pretty commonly cited target for herd immunity. So how much does it vary between states for total vaccinations? Well, the high actually is in Vermont. It has about 136 doses per 100. So remember, a lot of the vaccines are 2-dose vaccines. The low is Mississippi. It's only about 63 doses per 100. So, more than a 2-to-1 difference between the high and the low in terms of vaccine delivery. And we have a similar pattern in Santa Barbara County, so steadily increasing. Early April, we peaked, and then it's been going down since then. Our numbers aren't that much different than, a little bit higher than the national average, but 56% of the population is vaccinated, 49% fully vaccinated, 67% of the eligible people vaccinated. So out of all the people that are eligible to get one, 2/3 have gotten one, which is reasonably good. And 58% of the eligible are fully vaccinated. So we're making progress, but we're making it at a slower rate than we were a month ago. All right, so that was my last data slide. So a couple closing comments. So for the current outbreaks, the model estimates a global total of about 220 million cases and about 6 million deaths, which is a 2.8% case fatality risk versus the current value of about 2.2. So again, it says predicts that it'll go up a little bit. It probably will. I don't know if it'll go up that much. The case forecast is the same as a month ago. The death prediction went down a little bit. It was 7 million last month, 6 million now, as more and more outbreaks are trending down. And again, as always, it assumes the current outbreaks resolve and there isn't a discontinuous resurgence like there continues to be, although it really is a lot less now than it was pretty much at any time over the last 15 months. So the world definitely looks different in degree, but not in category. You know, we still have resurgence, we still have cases and deaths moving around the world, but not with the degree of change that we saw really up until now. And as I mentioned, over the last couple of months, case fatality risk shifted up slightly, and then it settled in. So it doesn't seem to be a long-term change right now in the case fatality risk driven by variants. And I would expect that with continued impact of the distribution of vaccines, case fatality risk will go down a lot once majority of people in the world are vaccinated. And you may still, as we see in the UK, see people get sick, but you won't see them die like they have been. And as always, the model can't forecast the probability of more outbreaks, just how the outbreaks that have been identified are going to proceed. So that was all I had for this month. So if anybody has any questions or comments, I'd be happy to have a discussion.
Just a comment that I found the whole mutation thing really interesting because I'm not an organic chemist, so that whole process was very fascinating.
Oh,
I thought it was very clear graphics to unravel something that's quite complicated.
it really is complicated. Yeah, thanks. That's good feedback.
Any other comments or questions?
Dave?
Yes, Sandra.
Is there any predictions of a booster shot? Have you come across any of that?
Yeah, I mean, there's a lot of discussion that there will need to be a booster shot for a couple reasons. One or two reasons, I think. One, just that in the studies that have been done so far, it looks like there's some number of months that immunity remains quite strong after vaccination or infection, and then that fades. So it's not like a measles vaccine, and it may need a booster shot, not more similar to the flu vaccine than many other vaccines. The other is that as the variants keep changing, if there does really become evident that there's a variant of high consequence that really evades the vaccine so effectively that people get really sick and die, even if they've been vaccinated, then I think that could also trigger the need for a booster shot to train the immune system on the new variant. But my personal opinion is, based on what I've read about the dissipation of the immune response over 6 months or 12 months, kind of in that time frame, that if there's still community transmission, we need to really ward off that booster shots may be a good idea.
Thank you.
Mm-hmm.
It's not really a booster shot. It's like getting a different flu vaccine every year. The next shot would not be necessarily.
No.
It could be a booster shot because of waning immunity, or it would be a newly constituted vaccine, more in line with what we go through yearly with the flu.
Exactly.
Any other questions or comments? No?
Thank you.
Okay, great. Thank you,
All
Dave.
right, thanks.
Those are great charts.
Thank
And
Thanks a
you.
lot.
see you
Yep,
next
thanks,
time.
Dave.
Thanks, everybody, for
Yeah.
attending.
Bye.
Bye-bye.
Bye-bye.